Stay. Alright, Roshan.
Are we going to be graded on our monkey exam?
No. I mean, I'm going to tell you what you get, but it doesn't count as a score. Yes. Number 11. Alright, I need everybody's attention. We need to get moving.
Alright.
The week after spring break.
Wait, e to the 1 is 0, right?
E to the 1 is e to the 1.
Oh, okay, isn't it e to the 0?
E to the 0 is 1. Alright, Ethan, what's my u on 11?
U is 2 square root of x.
No.
Square root of x.
Square root of x.
They said it was on the bottom.
No. I said if you have more than one e, and there's one on the bottom, then you want it to be the bottom. But in this case, I only have one e.
Okay.
If there's only one e, it's always whatever the exponent is.
Okay, I see what you're doing.
You need me to continue?
No, I'm good.
Anybody else need me to continue on this one?
What did you get? Yeah, what did you get? What did you get on it? What's the answer?
So my derivative is going to be that, which I have both of. So that means I'm just dealing with e to the u du. I've got to change my limits. So I plug in 1, which gives me 1. I plug in 9, which gives me 3. Integrate e to the u, I get e to the u. There's my answer. E cubed minus e.
Wait.
All right, what else we got?
9.
Zach?
12.
12. One of those that's so simple, it trips you up. All right, 12 does not require a u. And if I integrate 1 over x, I get natural log of x, absolute value of x. We're going from 1 to, is that e cubed?
Yes.
E cubed, so I plug in. We all know the natural log of 1 is 0, and we know the natural log of e cubed is 3, so I end up with 3.
See, I don't know what natural log of e cubed is.
Remember, these two cancel each other out.
Oh.
Mallard, do you have a question?
We are 9.
9.
I think I just did it wrong. Like, I don't think I was thinking right when I did it.
Alright, on this one I have more than one e, but I do not have a fraction. Whenever you have more than one e and you don't have a fraction, then u is going to be the e that's inside of something. So that means u is going to be e to the negative x. And by e to the negative x, I mean the e to the negative x that's inside. So my derivative is going to be negative e to the negative x dx. So the e to the negative x takes care of this. I got the dx taken care of. I just need to take care of the negative. So I get a negative there, and then we have tangent of u du, which we learned the other day is a negative natural log absolute value cosine plus c. So my negatives cancel here. Natural log absolute value cosine e to the negative x plus c.
What do you get cosine u at?
That's, you should have this memorized. If you integrate tangent, you get that.
Okay.
You should have it memorized.
Okay. I don't remember ever having. I know I probably have.
That's what we did on
So
Monday.
you said the video.
That was on the video from Monday.
Some stuff stuck in that video.
Anything else? We're showing 5. Yeah, 5. Hopefully you got my hint that I sent out on Remind last night. What was my hint I said on 5? Multiply it out. So this is going to be e to the x plus e to the negative x times e to the x plus e to the negative x. I need to multiply that out. So e to the x times the e to the x is e to the 2x. Remember, when you multiply two things together, what do you do with the exponents? Add them. So that times that gives me e to the 2x. This times this. What happens when I add my exponents? It gives me 0. So that's plus e to the 0. Same thing on these two. That's going to give me e to the 0 as well. And then the last two, what am I going to get out of that when I multiply? E to the negative 2x dx. Both of those are what? 1. And then I just need to integrate each one of those by itself, which we should be able to do. What does this one integrate to? 1/2 e to the 2x. This is just 2x. And this one, negative 1/2 e to the negative 2x. Let's see. Anything else? Fourteen. All right, moving on after 14.
Look away.
Sure. All right, 14. We've got an exponential that has a base other than e, but we want to treat it like e. So if I was looking at e, what would my u be? Sine of x. So the derivative of sine is cosine x dx. So cosine x and dx are both present. So we're just looking at 2 to the u du. All right, somebody raise your hand and tell me how we integrate 2 to the u du. John Ryan?
1 over the natural log of 2 times 2 to the u.
Very good. And then stick your u back in. Which is sine of x. There it is. Actually remembered on my own today, Karen. Proud of me. What we're doing today is kind of out of order. It's something random that AP added to Calc 2 years ago. So we're going to throw it in here. If it shows up on the Calc test, there'll only be one question. It's pretty easy to do. And you don't have to totally understand what's going on to get it right. So there are different levels of explanation on how I'm going to explain this.
This looks like a foreign language.
All right.
It's called death.
So we didn't ever talk about it, but there's an actual definition to a definite integral, as you see up here on the top. Now they made an error on writing it. Right here where it says x to infinity, it should say n to infinity. So make that change. I got this off from College Board, from the AP people, and that's a mistake. That should be n. So what they want you to be able to do is they want you to be able to go back and forth. Take a definite integral, turn it into a limit of a Riemann sum, okay? Or summation notation is what we have here, and go back and forth, okay? So what I want to do is I want to show you how to transfer back and forth without really giving you the reason why this is that, if we have time and you're interested, then I can show you where that comes from. Okay, but right now we're just going to take it as this is a definition, and I need to work from this definition. Okay, so let's look at it and see what we can figure out the key points are that we need to understand. Okay, so first of all, this little triangle x, does anybody know how we say that? How do you say that?
Delta.
Delta x is okay. Change of x is how we want to do it. Delta x and change of x is the same thing. Okay, so this just stands for the change in x. Okay, so as you notice, the change of x is identified as b minus a over n. So if you go back to your integral, I've got my b minus a right here. Okay, so if I'm going from here to there, I'm going to look at this, and that's always going to tell me the difference between my limits. Okay, the top number will always give me the difference between my limits up here. Okay, so the b minus a over n is going to be here. Okay, so if you look down here and I look at this, that means the difference between my limits has to be what on this problem? 6. So if you look at this, I can't read it though. It says 4 to 6. All right, so this is the one where it says we have to replace something with 2. So on this one, this actually is going to be a 2. This is what we're going to fix. So I picked the bad one. Okay, but so let's go to this one. What does this 5 mean? It's the difference in my limit. So what do you have between 7 and 2? 5. Okay, so this is always going to be the difference in your limit. All right. Then I go inside. Next thing I want to notice is A. What does A represent? My bottom limit. Notice it's my bottom limit. So if I come in here and I look at this right here, that means 4 has to be the bottom limit. If you come over here, there's 4 at your bottom limit. Okay, so on the next one, my bottom limit is also, it says 4, but what is it supposed to be? 2. It's supposed to be 2, so that's the thing that needs to be changed on that. Okay, so far, what's on top of the n tells me the difference between my limits. What's out here by itself is my lower limit. So if I have the lower limit and I have the difference between the limits, then I can automatically get the upper limit. Okay? And then we need to notice that this right here, also the change of x, this thing is going to show up twice, as you see here. So it's going to show up there and it's going to show up there. Okay? So that's all I really have to key in on, are these three things right here. That, and that. That's all I need. Okay? And over here, my limits are what I need to key in on. Okay? So it's going to be the lower limit plus whatever this is times I. And if you notice, this is inside of F. So this is always going to be placed wherever X would be. Okay? So if I come to this right here, my lower limit is 4. So I'm going to have 4 and then plus the change in X. So how far is it from top to bottom? 2. So plus 2 over n. And then I need times I. Now this whole thing right here needs to go where? It goes in place of the X. So if you notice, the X would be right here, and then what we just had goes there. Okay? Okay, and then we've got the plus 5, which is right here. That's why there's a plus 5. And then this is where we need to make the correction. Instead of a 6, there should have been a 2 there.
Wait, watch the difference.
Because the difference, between the difference there is 2. With me on that? Okay, so we found the issue on the next one. What was the issue on the next one? The second 4 should have been a 2. Yes.
So if you're replacing that inside part where x is, like on the first one it has 3x squared, so that quantity inside is squared, but like on the second one, the quantity inside is squared, but 4x isn't squared.
So this should not be, that should not be there as well. Good.
Since it's 4x minus 1 and nothing.
It should say 4 and then this and then minus 1. So this one had 2 errors in it.
So what if it was 4x minus 1 squared? Would it be squared outside the bracket? Or?
If it was 4x minus 1 squared, then yes, outside the bracket I have a square there.
So what if it was like 4x squared? Would it be squared outside the parentheses?
It'd be a squared outside the parentheses. Alright, so anybody pick up the error on the third one?
No, it's Q instead of square.
Should be Q, it should be a square right here instead of a Q? Okay, good. So that should be a square. All right, what about the next one? What's the error on the next
The
one?
4 should be a 2.
The 4, this 4 right here should be a 2. Good. Is that all of them, or is there one more on that?
I don't know if we lost.
There's one more. So on the next one, anybody pick up an error on the next one? The inside right here, that should be a 2. All right, so let's go to the next page. All right, so on this one, it's going to give me the limit of the Riemann sum, and then we want to translate it into the integral. All right, so I'm going to do it over here so I can write bigger. All right, can anybody get me started on number 1? Just give me a piece of it. Ethan?
Is A equal to?
A is equal to what?
2?
No.
A should be 1.
Roshan?
Is f of x 2x plus 1?
F of x, that's close. Ryan?
Your integrating function is 2x plus
No.
1. Square root of 2x plus 1.
Square root of 2x plus 1. So my function in here is that.
But how is your A not 2? Because it says
Is it not 1?
No.
Is it 0?
It's 0. Abby, why is it 0?
Because there's nothing, like, in front of it that's it. It's not adding anything to it.
Right. If you notice, there's always a number plus my fraction, a number plus my fraction, a number plus my fraction. So if there is no number plus my fraction, then that means I'm starting with 0.
so what you're saying is like right there it's 2. Technically, actually, or 2 is the coefficient, it's not the A.
Right. 2 is a coefficient in front of the x.
So if it would have been like 2, if it would have been 2 outside the square root, that would have been your A.
No. If I were to have an A right here, I'd have had to have something like 3 plus 6 over n and an I. So did anybody else notice that the I is missing on this problem? Yeah, so that's another mistake they made. So this worksheet is only 2 years old. They made it 2 years ago, and I don't know why they haven't fixed it yet, but they haven't. Hunter?
I was going to say that B is 6. Is it 6?
Say it again.
That B is 6.
B is 6. So we're starting at 0. The change is 6. So yes, that's 6. All right, and then we throw in the dx. There it is. That's all you got to be able to do. Okay? All you got to be able to do is go from here to there and from there to there. All right, number 2. Okay, somebody else get me started on number 2. Mallory?
A is -2.
A is -2. I agree with that. All right, somebody else. Abby?
B is 3.
B is 3. So -2 plus 5 does give me 3. Good.
That's like,
Zach?
so what if that would have been like -2 parentheses 5i over n? That would have worked in for A.
So -2 and then parentheses
Yeah,
5i,
so it's like -2 times 5i.
then my A would have been 0.
So as long as you're like delta, whatever it's called, the equation, something b minus a over n times I, as long as that's separated from the number on the left by the plus or minus, it's your A. But if multiplied together, it doesn't.
All right, there's no A. All right, somebody else. Ethan?
Is the function x squared minus 3?
Function is x squared minus 3 dx. Very good.
Yes.
Okay. Very good. All right, number 3. Natalie, give me something on number 3. Give me a piece of it on number 3.
Is your A 0?
Number 3, my A is not 0.
Could be minus 4.
Haley?
1?
1. My A is 1. Everybody understand why?
No.
In here, I've got the 5i over n, and I'm adding 1 in
shoot.
front of it. So that means 1 is my A.
I was the wrong one.
All right, Jarrell, what's my B going to be?
6.
6. Very good. Everybody good on where we got 6? All right. Jennifer, what's my function? 3x minus 4. Nailed it. Perfect. Nicely done. All right, Brady, give me something on 4.
Your A is -2.
A is -2. Good. Lilani, what's my B?
4.
4 is my B. Maddie, what's my function?
X cubed.
X cubed. Everybody good on that? Anything I need to clear up?
Does he want to complicate after this, or just?
That's it. That's it. All right, 5. Courtney, give me something on 5.
The bottom one is -2.
All right, my A is -2. Very good. Advait, give me something else on number 5.
Your function, the square root of x squared plus 1.
Square root of x squared plus 1. All right, John Ryan, what's my B?
0.
My B is 0. Very good. Good stuff. 6. Elias, give me something on 6. A is 2. Very good. Abby Davis, give me something else.
B is 6.
B is 6. All right. Abby McNeely, something else.
Your function is 5x plus 7.
5x plus 7. Perfect. Sounds like you guys got it. All right, number 7. Hunter, give me something on 7.
A is 0.
A is 0. Everybody good with the A being 0? Okay, good. All right, Natalie, what's B? 4, good. Natty, what's my function?
6x squared minus 2.
6x squared minus 2. Nicely done. All right. Lilani, 8.
A is 1.
A is 1. Elite,
B is 3.
B is 3. Courtney, number 8. I need the function.
X cubed minus 1.
X cubed minus 1. All right, anybody have any issues translating from the limit of a Riemann into an integral?
I
Yes.
just have a question. Like, so an AP test, are they going to give us like a formula sheet that has the definition of a definite integral? So you have to have that memorized.
Do they give you like any formulas at all?
Yes, they will.
Probably that one is the
Like complicated volume formulas that give you, but almost anything calculus related, then I will give you. All right, next page. Hopefully the next page goes the other direction. No, it doesn't. Yeah, it does. No, it doesn't. That's all right. More practice on this.
Not a tornado drill, Coach White.
There is.
What?
So what time?
It's just like a PM academic enhancement, so we got 15 more minutes. Actually, yeah, 45.
Are you giving us a like homework over this? Okay, good. No, you cannot.
No homework. All right, here we go. Elias, back to you. The top one.
They're missing some eyes. Are they?
Yes, they're missing. Let's skip the
Yeah,
first one. The first one's jacked up. Let's go to the second one.
What?
Elias, go to the second one.
Is A 3?
A is 3. All right, Haley.
B is 9.
B is 9.
Coach White.
Zach.
Oh. Is it 4 minus the square root of x squared? Or, oh, 9, it's 4 minus the square root of 9 minus x squared. It's not x squared. You know, x minus 6 squared. There you go. I have a question.
When the whole thing is squared.
So basically, when you do like, if you do like these long problems, you just look where the 6i is to find the a. Okay.
That's your anchor. Yes. All right, Darrell. Next one.
Your A would be 0.
All right. Abby M. Jennifer?
2/3 x plus 2.
Very good. All right, Roshan, next one.
You want A is 0.
No. -2. Abby D. D is 0. All right, Mallory.
The square root of 4 minus x squared.
Very nice. Brady, next one. We're skipping that one. Go the one after that.
Is
16. Alidi.
B is 22.
All right. Courtney.
2/3. Oh wait. Yeah. 2/3 x. Oh wait. I don't know. Oh wait, minus 19. I got confused looking at it.
Make sure the x minus 19 is in parentheses on that. You guys see that?
Is double parentheses, is that right?
Yep. All right. Let me give you some integrals, and then let's go the other direction.
What about the value of definite integral?
We're not going to mess with it. I'm just wanting to translate. I want to get the translations done. All right. So let's go -1 to 4. Let's go sine of x
Why are you pulling trig into this?
squared dx.
Wait, is that a negative?
-1. That's correct. All right, Abby, you going to get us going?
Oh, sure.
All right, I'll go ahead and put the stuff that's in there every time. Or if that's in it.
I don't.
Now, you're not, here's the deal on this, is when this shows up, it's going to be multiple choice. Okay, so you're not going to have to come up with this part of it on your own. It's going to be there. Okay, so you're just going to have to worry about what's this part. Okay, is all you've got to figure out. All right, who wants to get me going over here? Roshan?
You start off with sine.
Start off with sine, and then inside of sine,
-1
-1.
plus. Is that 5i over n?
5i, I like doing 5n and I, but you can do whatever you want. 5i over n is fine. And then I've got that. And then the last thing is 5 over n. Perfect.
What about the square?
Oh, yeah, we need the square. Thank you. We need the square right there. So close.
Well, I was just confused where it went.
Yeah, you're good. All right. Who wants to get me on this one? Abby?
Okay, 2 over. What is that? Is it 2?
This is a 2.
Okay, 2 plus 6i over a parentheses 3.
So I need a cube here,
Oh, yeah.
and then I need a 6 over in there.
Wait, so 6 over n will be multiplied times the whole thing?
Yep.
Not just the denominator?
Everything.
So if you try to
They do.
multiply all that, you'll get back to sine of x squared. Will you get sine of x squared?
Say it again.
If you try to multiply that stuff back together, will you get sine x squared? Or like,
You're talking about this thing?
or I mean, or I'll think of the bottom things, but
All right. So these are 2 different problems.
or whatever. Would you when you multiply the bottom thing?
When I work this together, am I going to get this?
Yes.
No. Here's what happens. If you work this and you work this, those 2 are the same.
That's what I was asking.
No, you weren't asking.
I was saying if you multiply those together.
No, you're asking the wrong.
When you put it together, what are you going to get that top?
If you evaluate this, yes, you're going to get the same as this. But it will not look like this. You will get the same answer as this.
So it won't be like.
It will not. This will not turn into this, and this will not turn into this. They will both produce the same value.
So like, so if it's 8 and 2 and plugged it in, we get the same values.
Say it again.
So let's say take 8 and 2 and plug them into it over x cubed, and then plug them into whatever we get from the bottom, we'll get the same answer.
Yes. If I were to integrate this and then plug in the 8 and 2 and work it out, and then if I were to work this out down here, I would get the same answer. Yes.
How do you even work them?
Yeah, I don't know.
Why did people say let's do this? Like why did people are like
I had a lot
this
back
gets
in the
this answer
day.
and this also gets this answer? So that means like these are the same. They're like that. Like why do people just think like let's just do this?
Well, here's the deal. Here's the deal: is this thing right here is shorthand for all of that. Is what it is. So instead of having to write this every time, they're like, "Hey, let's do this instead."
Wait, no, what were you gonna say back in the day?
Back in the day, they had a lot of time.
Apparently,
They didn't have Xboxes or phones or whatever else to occupy your time with.
you know,
But why
I
do
don't
they-
appreciate these
They
people
They did math
coming
for
up
fun.
with
I
these
mean, I did
things.
math for fun, but they did math for fun.
So if you like create an equation, do you get to name it?
I mean, I don't know about equations.
Can you even like
There's probably
create
there's
any
not
more
much left.
equations
There's not much left to come up with.
But why?
Is there like a calculator and no calculator portion of
The test is in 4 different parts. First part is multiple choice, no calculator. Second part is multiple choice with a calculator. Third part is 2 free response questions with a calculator. The last part is 4 free response questions without. So that's the whole thing.
What if your thing?
What?
Your
How
calculator
many
shot
minutes is the 2 question?
And the 2 questions, you get 15 minutes per free response question.
You get 15 minutes.
That's a big question.
Can we practice some
15.
time to like?
That's what Mock's for.
Well, I mean like individual like work problems.